Good morning, Algebra 2. Got another day today. Today we get to look at Chapter 16, where we're going to be working with logarithms, which once again are the inverse of exponentials. So again, I think you'll really enjoy this chapter. I enjoyed it. Section 16-1, we're going to look at the properties of logarithms. And in other words, we're going to take the time and we're going to add, we're going to subtract, we're going to multiply and divide logarithms. And again, it's a little bit different than what we normally know about adding, subtracting, and multiplying, but I think you'll have no problem, okay? So I think about the only way to do this is by example, so I'm not going to focus on the explore part. So what I want to focus on is pretty much the properties of logarithms. And again, it's also visible on your HD&Cs on page 21. And we're going to run across 5 different properties. All of them have a different function, or not in the sense of the function that we've been talking about, but they all have a different way of dealing with logarithms. And the first one is dealing with probably 3 of the main ones that you're going to run across is here is, when you look at properties, it's almost like simplification. How do we simplify a logarithm? So what we're doing in here is either we're going to simplify a logarithm into a 1 logarithm, or we can evaluate it, or we're going to get into another area of logarithms where we're going to expand, or we're going to compress logarithm expressions. And that all comes from these 5 rules. The first rule that we're going to run across is this one. This is a basic problem. It says if we have a log base b of some b raised to the m power, it's always going to be m. This is going to be very, very important. We're going to see the use of this in a lot. Again, log base b of 1 is 0. Now again, if you remember now, it's just going back, we can take a log and we can write it as an exponential. So in other words, it's going to be b to the 0 we know is going to be 1. Okay, and then this property right here, log base b of b is 1. And now the next one is dealing with the product property of logarithms. And again, if I have a product and I want to find the log of that, we can take this product and we can make it into an addition statement. Now, we didn't go into how that came about, but you just have to take this as a statement of fact. And then stop and think of it. This part right here is what we're dealing with, and we're going to this part right here. This is called the expansion. And now if we go from here back to here, this is a compression. So again, these are the rules that we're going to be using. Here's the quotient property of logarithms. In other words, if I have a logarithm and I'm dealing with a fraction, I can split it up into a subtraction statement. Then the powers of logarithms, again, if I have log base b of m raised to the n, I can rewrite it in this form. We'll see use of these throughout this whole section. Now the next one is called the change of base property of logarithms, because all these problems up here, they all have the same base. But what happens if we have we have 2 logarithms that have different bases? Now again, I'm not a big fan of this one, but so I want you to write these 2 down, because these 2 you can use on your calculator. The first one is the log 1, and the second one is the natural log 1. Again, these are the 2 that we're going to be focusing on. In other words, just to let you know, this, if we were to define the change of base of this or the change of this, you're still going to get the same answer. So it does not matter which one of these you want to use. All right, the only way to do these problems is just show you by example, okay? How do these properties of logarithms work? So if you take your textbook and again, explain 1 is how do we use it. Now again, the key to this section is looking at the directions. So again, here it says we want to express each expression as a single logarithm. The reason I'm bringing that up is because if you see here, this has 2 logarithms. And if we are able to simplify it, we're going to do that. Now again, we could have easily just plugged this into our calculator. But again, I like, we don't have to really be dependent upon our calculator all the time. We're going to go and use the properties of logarithms to deal with this. All right, so here's our problem. The first thing we want to do is to go ahead, we want to go and put this as a single logarithm. So right now we have two logarithms. And if you see this right here, that's a subtraction. So that means I can take this statement and make it into a division or a quotient. All right. The next line is what they did next is they took 27 and divided by 81. So again, you could have used your calculator on that one. And that's where they get the 1/3. Now the next thing we got to do is, in order for us to go further, we got to make sure that this base right here and the base of what we're trying to find here is the same. So that's what they're doing here. So we have to go and rewrite this so that we can use the same base. All right. Then the next thing is done is they got a -1 here in the power, so we can go and apply the power property of logarithms. And then this part right here, you see this part right here? Log base 3 of 3. If you go back to this rule up here, say we have log base 3 of 3. Well, yeah, this right here is just going to be whatever. Oh, I'm sorry. Yeah, it's going to be that one right there. It's going to be whatever m is. So again, in this case, log base 3 of 3 is 1. And then we know -1 times 1 is -1. All right. These are just, you just got to think ahead on some of these problems. I think you're going to have no problems. All right, let's look at another example. You can just go ahead and stop the video and write this information. Well, you don't have to. Let's just do it. First thing first, we have an addition statement, so that tells me that this is a product. So I can rewrite it as a product. So again, here, from down here, you could have used your calculator. 625 divided by 25. That gets us 25. Now the next part here is we see that we have a log base 5, so we have to take the 25 and make it into a base of 5. So I know that 5 squared is 25. Then next step is using your power property. So we bring the 2 out here into the front. Once again, log base 5 of 5 is always 1, and 2 times 1 is 2. Yes, we could have used our calculator, but we got to start learning how to use our log properties. All right, what I want to do next is go way at the bottom of your year turns, and we have 2 problems to work out. Here's what I'm going to do. I'm going to do number 5, and then you guys can go and do well, I'll just show it to you guys, okay? So let's start off with the first one. We have log base 4 of 64 cubed. The first thing we could do is the power property. So I can bring the 3 in front of the logarithm. Next thing we got to do is that we have a base of 4. So we got to take this 64 and see if it has a base of 4, which it does. And we know that 4 raised to the 3rd power is 64. So I can rewrite that. Now we can go and do another power property. Again, 3 times 3, where we got this part right here. Left with log base 4 of 4. And once again, log base 4 of 4 is 1. And so 3 times 3 times 1 is 9. So we just simplified this one. Yes, we could have used our calculator, but we've got to start learning how to use our log properties. All right, number 5. Next thing here, we have 2 logs. So that tells me I have to use the division power of logarithms because we have a subtraction. We know 18 divided by 2 is 9. Now the next part here, see over here and this one over here, see the 64, well, see this 4, 64, they have the same base. They both have the same base of 4. But if you go over to this one, we have log base 8 of 9. Guess what? This is a base of 8. 9 does not have a base of 8. 9 has a base of 3. So what happens now, we have different types of bases. So this is where we go ahead and use the change of base formula that I showed you that was shown in the rules earlier, right up here. We have different bases. I'm using this one. Okay, so it's very simple. You can use any of those two. I'm going to do both of them. So we can log base 9, so that we have to use the log button. Log base 9 divided by log base 8. And we get 1.05664. Okay, and I just rounded up to the nearest hundredth or thousandth. Now we can also use an ln. Okay, you'll get the same answer. So ln of 9 divided by the ln of 8, and you get the same answer. So when you go back to the change of base formula, it does not matter if you use this one or this one. It doesn't matter. All right. Okay, going back, yes, we could have used our calculator, but if we have an older calculator that may not have this feature of, well, once again, you're probably saying, what feature are we talking about? So you go back to math, okay? And if you see, if you have this one on your calculator, yeah, we could have done all this stuff. But what if you have a calculator that doesn't have it? So that's why we have to use the log of base. All right, now before I move on, I'm going to just go back over this part. You see it once again. Log base 8 of 9. We know 9 does not have a base of 8, so that's why we have to use the change of base formula. All right, now, what I want to do is do a couple of problems from the homework pages, and I like to do some of the evens, okay? So let's go to page 790, and let's look at number 6. All right, now don't let these confuse you, because they're all using the same rules, okay? All right, so first things first, here's our original problem. We have the log of log 798 minus log 702, all raised to the x power. Now, this is the part of simplification of logarithms you need to get in a practice of, okay? It's like the order of operations. We work with the innermost parentheses work first. So if we work with the innermost parentheses here, we notice that we have a subtraction here. So that tells us we can do a division. So we have 98 divided by 2. Remember, now, don't forget all your order of operations. All right, the next thing you can do is, well, I know 98 divided by 2 is 49. Okay. Now remember, now we're still going to focus on the inside, so I'm going to hide that. So we just deal with the log base 7 of 49. Well, again, I know 49 has a base of 7, so I can write it as log base 7 of 7 squared. Then the next step is your power rule. We have a 7 squared right here, so I can take the 2 and put it in front of the log. You with me so far? Now we see again, log base 7 of 7 is 1. And 1 times 2 is 2. All right, now the next one here, we can use our power rule. That's going to be x log 2. Now, as a matter of fact, right now, if we want, we have taken this whole log right here and made it into one expression. We have, in this case, we have a multiple of logs here. We have just simplified it into one log statement. But we can go further, okay? Because we can use our calculator now. So we know that log base 2, log of 2, is 0.030 whatever, and I just round it to the nearest thousandth times x. So again, the simplification or the answer to this, okay, is 0.301x. We're done. All right, now let's go to number 8. All right, now this one, we have log base 4 of 5 plus log base 4 of 12 minus log base 4 of 3.75. Now we have 3 log expressions. So what we got to do is get it down to one log expression so that if we're able to, we can simplify it. Again, now, order of operations. First thing we got to do is take care of this expression right here, because you got to do your order of operations. Again, remember now this guy right here means multiply. Okay, so that's where we get the log base 4, 5 times 12, which is log of 60, log base 4 of 60. Now we have a subtraction, so we can do the division property. So that's 60 divided by 3.75. So we can use our calculator now. 60 divided by 3.75 is 16. So we get log base 4 of 16. Now again, we have log base 4 of 16, so we got to get the 16 to have the same base of 4. So we already know that 4 squared is 16. Power rule, 2 times the log 4 of 4. And once again, log base 4 of 4, once again, is always 1. And 1 times 2 is 2. So this is what section 16-1 is about. And again, I forgot to tell at the beginning of the video that we're going to do this in 2 parts. These are the simplification part. The next part is we're going to do word problems. All right, guys. Thank you very much. Have another video in a little bit. All right, bye.